Hello everyone, this is second lecture of data structure by CurioTech. This is Suchi and here we are going in this lecture about types of data structure. We already went through what data structure is and we got a better understanding of it, and we only know that now we know that organizing and storing data so that the operations like searching, inserting, deleting and updating becomes efficient, right? That is what data structure is, isn't it? So here are the two types of data structure. First is primitive data type and second is non-primitive data type. So what does this primitive data structure means? Primitive data structure are the basic data types provided by the programming languages. Alright, that means they can store only one value at a time. When we are talking about primitive data structures, that means they can store only one value at a time. Alright, let's talk about the first type of the primitive data type, that is integer. If I am talking about integer, let's take an example. I can say that int a is equals to 20. This a is the variable, this int is the data type and this is the 20 is the value, which is the integer value. And when I am talking about primitive data structure, that means it can store only one value at a time, right? Next is float. This data type stores decimal numbers. For example, float, which is a data type, pi, which will be a variable, and 3.14 is the value, right? That means this variable pi is of float data type and stores the value 3.14. Next is character data type. That means it stores a single character. For example, char, it is the character data type. So we will be using char for it. Then let's say a variable which is grade and assign it a. Alright, that means this char is a data type, this grade is a variable and this is the value that has been assigned to it. Alright, now next is the pointer data type. Pointers a variable. Pointers are the special data type and also interesting, by the way. So what it is? Pointers are the variables that stores the address of the another variable. I am saying is pointers are the variables that stores the address of the another variable. That means instead of storing data directly, it stores where the data is located in the memory. What I mean is, suppose example, int a is equals to 10. Now we are going for pointer. So int asterisk ptr equals to n a. Now what it means is, this variable ptr holds the address of the variable which is a, and in this a variable the value that is 10 is stored. That means it stores the address of the another variable. Alright. Now this is the part of primitive data structure. Now we will be going for non-primitive data structures. Alright. Now what are non-primitive data structure? What could be non-primitive data structures? These data structures are built using the primitive data types. Now what I am saying is, these data structures are built by using primitive data types. That means it can store multiple values and organize them in a way that makes the data processing efficient. that makes the data processing efficient. In the primitive data structure, we could only store the one value. Now, in non-primitive data structures, we can store multiple values. All right. These non-primitive data structures are divided into two parts, that is linear data structure and non-linear data structure. Now, what does it mean by linear and non-linear data structure? When I am talking about linear data structure, that is these, and this one is non-linear data structure. When I am talking about linear data structure, which would be arrays, linked list, stack and queues, that means this data structure or these data structures are the ones in which elements are arranged sequentially or one after another. All right. And when I am talking about non-linear data structure, that means tree, graph, that means these data structures are the ones in which elements are not arranged sequentially. All right. So, this is the clear difference of linear and non-linear data structures. All right. Now, we can also say that in non-linear data structure, one element can be connected to a multiple elements. All right, like creating a hierarchical or network-like structure, but that is not the case when we are talking about the linear data structures. All the elements are arranged sequentially. All right, there is no random connection in between. That is the one clear difference of linear and non-linear data structure. Now, let us go on with the linear data structure. When we are talking about linear data structure, the first one is arrays. Now, what are arrays? What are arrays is, these array is a linear data structure. It stores multiple elements of the same data type. This is about array. All right. Now, these store same data type in a contiguous memory location. The second point is contiguous memory. Now, in the array, there are two points. First is same data type and the contiguous memory location. Means, suppose there is an integer data type, this is the variable, and it can only store, now if the data type is of integer, that means it can only store which kind of data? It would only be integer kind of data. All right. Now, if I take one real life example of it, let me clear this. If I take real life example of it, that means it would be students sitting in a row where every seat has a seat number. Now, if I am taking this example, that means you can understand it like this, that every sequence of element has a proper number. That means the arrays include indexing. Now, which are the elements that I assigned it first? Suppose, let me write it again, array and 10, 20, 30 and 40, right. Next is, so this will be allocated in memory something like this. Here is one indexed and here is one value. So, arrays always start from 0, 1, 2 and 3. There is the index and the data will be stored something like this. So, this is how it goes. So, when I am taking a real life example that students are sitting in a row where every seat has a seat number, that means this every data has a particular index number to it. All right. Now, let me erase this. Next part is linked list. We will be going through all of these data structures one by one thoroughly in a separate video, but I am giving you introduction so that you have a brief overview about every data structure. Now, linked list. as array has a contiguous memory location, but linked list doesn't have contiguous memory location. A linked list is a data structure in which each element is called node. All the element is called node, and it contains data and the address of the next node. That means there is data and there is address, and this particular is called node. Alright, means there would be one node which would contain data in one block and address in another. Alright, the nodes are not stored in contiguous memory. Alright, for example, for a real life example, a treasure hunt where each clue tells you where to find the next clue, right? That means this data and the address is contained by one node, and if there is another node, that means the address of the next node, suppose node 2, this is node 1, the address of the next node will be contained by the node 1 address part. Alright, and there would be some data in node 2, and there would be address of the another node if there exists any, otherwise it will be null. Alright, that is the brief overview of linked list. So what happens is, when we are working in array, it is stored in a contiguous memory location. So when we are defining that particular array, we have to define the size of it. Then it stores or it finds an array size in that memory of that particular size that is given in the array. Now it is a contiguous size, so it finds in the memory where that particular block is available. But when we are talking about linked list, it takes the particular space according to the data type that is defined for the node, and it allocates all those nodes randomly in the whole memory of your computer. Alright, wherever the space is available, it will allocate the memory to that particular node. So that means they are not contiguous. Next part is stack, or next type is stack. So stack works on last in, first out. When suppose example, stack of book, stack of plates, right? If I am making a stack of books, so whichever is the last book will be taken out first, and similarly if I am talking about the stack of plates, so then it is like whichever is the last plate will be removed first. So stack is a linear data structure that follows LIFO, that is last in first out principle. The last element inserted is the first one removed. It works on two principles, that is push and pop. The push is for insertion, push is for insertion, and pop is for deletion. Alright. Next is queue. Next type is queue. It follows first in first out. First in first out. You can talk. We can take an example of a queue. Registration queue or a ticket counter, right? So if you are first in line, you will be served first. So queue works on a FIFO principle, right? So people waiting in a ticket counter queue would be the best example of explaining queue. Next is non-linear data structure, and the first example is tree. So tree is a non-linear data structure that organizes data in a hierarchical manner. Hierarchical manner means it follows a particular hierarchy, that is of parent-child relationship. It starts with a root node. It starts with the root node. Suppose this A is the root node and B would be the child of it, C would be the child of it, and similarly D, E. Alright. So, this is a type of, or this is the representation of a tree. Next is graph. A graph is a non-linear data structure that consists of a vertices. Vertices are called nodes. It is connected by the edges. These are called vertices. These nodes are called vertices, and these are called edges. Alright. It is made of vertices and edges. A node can be connected to multiple other nodes. These nodes can be connected to multiple other nodes. Alright. So, this becomes a graph. If I am talking about a real life example in graph, it could be Google Maps, Facebook friend request, airline routes, or a computer network. Alright. The last part is files. So, what file is it? Is that it is a collection of related data stored permanently on a secondary storage, such as like SSD or hard disk that you use. So, the data that is stored permanently, it is for a foundational view, you can think of it as a file. It is used to save information for the future use. So, this is all about the types of data structure. Hope you enjoyed it. If you like my video, so please do like and subscribe to the channel. Thank you so much. I'll be coming with a next video in the next lecture.